All right, hello, my dear friends. Today I'm doing this question from the November 23 AA HL session. I'm really focusing more on part A for the integration techniques, and part B is more trivial, so I'm not going to bother too much. So, if we look at our integral, this is an indefinite integral. First of all, we know there are no bounds. So, what are some techniques we can use? We see that we have a product of two functions, so what should come to mind should be integration by parts. To recall, this here is the definition for integration by parts, and below is a mnemonic I like to use to remember or to rather find what function I'd like to use as my u variable. And it says that we should consider inverse trig first, then logarithmic, then algebraic like x squared, 2x, then our trigonometric functions, then exponential functions like e to the x. So clearly we have a choice here of using ln x squared as our u because it is in fact logarithmic. So we can write that integral of x ln x squared dx, use integration by parts. So we choose u to be ln x squared and dv is x dx. So differentiating our u, we get du is equal to 2 ln x over x dx, and v, we're really integrating dv here, so it's integral of x dx, which is x squared over 2. V is x squared over 2. So now we can apply integration by parts. Again, remember it says that the integral of u dv is uv minus integral of v du. So u is ln x squared, v is x squared over 2, v is again x squared over 2, and our du is 2 ln x over x dx. So now we have a sort of complicated integral, and first of all we can look inside our integrand here and see that we have something to in fact simplify. So we can factor or no cancel out one of these x's, it leaves one x, and these 2's get cancelled out, which leaves us with only x ln x dx. So that is a bit nicer for us. So we can do integration by parts again. And this time we have another logarithmic function. So we use ln x as u, and dv is x dx. So if we differentiate u, we get 1 over x dx, and we can integrate dv to get x squared over 2 again. Yep, so this is our setup for our second integration by parts. We can, let's just call this integral by itself I2 now for clearer writing. So I2 is uv, which is ln x multiplied by x squared over 2, minus the integral of v, which is x squared over 2, multiplied by du, which is 1 over x dx. So now we have our first expression, ln x times x squared over 2, minus this integral can be simplified again. We have x left and then only a 2. So I'm going to factor out this half, leaving me with just x. This is simple enough. And this becomes x squared over 4 if we multiply the two 2's. So yeah, this is our expression for I2, and now we just have to put this back into our whole I. I'm just going to bring it up here so we can see better. So I is equal to x squared over 2 multiplied by ln x squared minus our integral, which we solved to be ln x multiplied by x squared over 2 minus x squared over 4. This is in brackets. Sorry, I forgot to write that. So we can take out the sign. This becomes addition. And in fact, that is our result. So our integral, indefinite integral, x times ln x squared comes out to this expression. I'm going to factor out a common factor of x squared over 4. So x squared over 2 divided by x squared over 4 leaves us with 2. So this leaves 2 ln x squared. The same thing is true for the second chunk. So we again have 2 ln x, and our last term is simply 1. So this is the result for part A, where they ask us to solve this indefinite integral. And I hope you enjoyed this video.